Hello, dear students. In this video of data mining, we'll discuss data warehouse schemas. This topic is also important from the examination point of view as well the data mining point of view whenever you are going to bifurcate your data and arrange the data. So first of all, you must have to understand what is a schema. But before going on that theory, you must have to see the actual diagram of the schemas. So basically, we are talking about our different tables or databases which are related to each others by using different keys. As we know that if we are talking about relational databases, then to develop that kind of thing, we must require keys, because that is only thing by which we can connect different tables or databases. So to better understand and better utilize that data, we develop different kind of schemas. So schema is logical description of the entire database, as we discussed. It includes the name and description of records of all record type, including all associated data, items, and aggregates. Much like databases, data warehouse also require to maintain a schema. A database uses a relational model, while a data warehouse uses. So we have three kind of data schemas, database schemas: star schema, Snowflake schema, and a fact Constellation schema. We will discuss on that in different slides. Now, first of all, we have to understand there we have two terminology: dimension table and fact table. So fact tables are the tables which contain which contain only keys, and dimension table which contain the data. So keep in mind, fact table contain the keys and dimension table contain the data. Okay. So we are talking about different kind of schemas, and first schema is star schema. So as we can see in the diagram, we will go on the theory, but before going on theory, we must have to see the diagram. We are seeing here we have a fact table. In this, we have different keys like transaction data, transaction ID, user ID, account ID, merchant ID, and amount. And that key table connected with different tables like dimension transactions, dimension users, dimension merchant, dimension accounts, and dimension dates. So these all are the dimension tables, and this one is the fact table. So that fact table will help to connect tables to each other. And here we can see that a fact table is connected with all the dimension tables, and we can realize here centralizedly fact table dealing with all the dimension tables. So that is a scenario of a star. So each dimension is in a star schema is represented with only one dimension table. This dimension table contains the set of the attributes. The following diagram show the sales data of a company with respect to the four dimension, namely time, item, branch, and location. So each and everything is very clear. I think there is no need to further explain these things because we already discussed these things. Now, second schema is a Snowflake schema. Now, keep in mind, the Snowflake schema is a normalized form of star schema. Some dimension tables in the Snowflake schema are normalized. This is the key thing which you have to keep in mind to remember Snowflake schema. So go on the diagram. We can see here we have a customer table, a website table, a country table, a region table, a transaction table, a date table, and TBD release table. What we are doing here, we are normalize the transaction table. Here we are making us additional table date. If you are not making that table, that means in each and every transaction, we must have to mention these all things with all these records. But if we are making that table, then we can just use the date ID instead of using repeatedly use that things. We can just use date ID. So what we are doing here, we are just creating one more table, a date table, to normalize transaction table to remove the redundancy. So that kind of way to implement a schema is known as a Snowflake schema. So the normalization split up the data into additional table. Unlike a star schema, the dimension table in a Snowflake schema are normalized. For example, the item dimension table in a star schema is normalized and is split into two-dimension table, namely item and supply table. So this is not a fixed table. You can make your own example to represent that. Just you have to normalize one of the table. That's it. So that way is known as Snowflake schema. Now the last one is the fact translation schema. This is also known as galaxy schema. A fact translation has multiple fact tables. It also known as galaxy schema. So here we can say that this is a combination of star schema as well Snowflake schema. So here will be a multiple dimension table as well multiple fact tables. So nothing complex here. The following diagram shows the fact table, namely sales and shipping. Here you can see the shipper dimension table is also here. Sales fact table is here. Time dimension table is here. Item dimension table is there. Shipping fact table is here. So what we are seeing here, we have multiple fact tables as well multiple dimension tables is here. So that is uh, fact translation schema. So this is the schemas in data warehouse. So this is your topic, database schema. Thank you.